Stanford University.
All right, well, welcome to Stanford CS193P, Developing Applications for iOS, winter of 2017. This is lecture 15, I think. Yeah, 14, something like that. And today is all demo. We're going to do a demo of this dynamic animation stuff. And I'm going to cover push behaviors and collision behaviors and dynamic item behaviors, collision delegates, gravity behaviors, etc. I'm not going to get back to the slides, so let me talk about what's coming up now, which is we have no section this week. And then next week, I actually posted what I'm going to be talking about next week, but it's application life cycle, alerts, action sheets, segues, might even get core motion to fit in there. I'll try and cover as much of the general infrastructure stuff that might help you with your assignment. Okay, so let's get right to the demo. And this, now we're demoing dynamic animator here, and generally dynamic animation is mostly used to animate things that are happening in your UI normally. And I use that example of when you swipe up from the bottom on your iPhone and it brings that little UI view comes up and it kind of bounces a little bit and then sits steady. That is really what dynamic animation kind of is used for the most. You wouldn't probably use it to build a video game, even though that's the demo I'm going to do today. There are other things like Sprite Kit and things like that that you might use for that. But I like doing the video game because it's kind of fun, and it also is an opportunity for me to quickly and densely show you lots of different kinds of behaviors and how they work. So we're going to build a space game, asteroid game. We're just going to have a field of asteroids flying by, and we're going to have a ship in the middle. And our ship is going to have some shields. And every time an asteroid hits the shields will turn on and get depleted. And eventually, our ship will probably be destroyed from too many asteroid hits. And we're going to be able to do all those behaviors that I mentioned before. So let's get started here. I'm going to create a new app. I'm going to call this app Asteroids. And we're going to make it work on both iPad and all the iPhones. That's no problem for this one. We'll put it in the same place we always put everything. Now, I want to focus all my demonstration time here on the dynamic animation stuff. So this is one of those demos where I actually do have some code and some stuff I'm going to drag in. I'll show it to you briefly, but it's mostly just drawing things, drawing the ship, drawing an asteroid. And all the animation stuff we're going to do, 100% of it is going to be in code that I do in the demo here. So let's start by moving some of these things out of the way as we usually do. Put these things in supporting files just to clean up what we're looking at here. I'll even put main storyboard up here. Now, I've left XC assets out of supporting files this time because I actually am going to have some assets, some image assets, specifically my asteroids and my ship. So let's drag those in. So I'm just going to go over here to this little directory I have of stuff. And you can see that I've got some kind of random pictures of asteroids here. And I'm just going to take these asteroids and add them to my images down here. I'm going to do it for explosion also. My ship knows how to explode, so we'll have that. And then here's my ship, cute little ship. Here's where its engines are firing. Okay, so we have those two images right there. Now, when you drag images into your XC assets, you'll see that they have a 1 times, a 2 times, and a 3 times slot. And that's talking about the resolution. Okay, it's really talking about the number of pixels per point, okay, in the size of the image. Normally, you're going to have all 3. I'm only going to use the 1x because my 1x is pretty high resolution. It'll look fine on 2x and 3x. But if you had a real app, you'd want to pick the resolutions at these different sizes because it allows a 1x app to be much smaller because obviously a low resolution is much smaller. And it's really cool, actually, when people download things from the App Store, you only get the resolutions that are appropriate for your device. So it's kind of fun. You don't get all that extra junk that you don't need. So anyway, so those are my images. And then I do have a little bit of code here, too. I have these 4 files, which, like I said, we're going to take a look at here and drag those in. And we will copy them, yes. All right, so let's look at the code we just dragged in there. First one here is asteroid view. This is the entire thing that you see on the screen right here. Very simple little subclass of UI image view. It just picks a random one of those asteroid images, right? See these asteroid images, 1, 2, up through asteroid 9. This thing just picks one of those and makes an image view out of it, okay? that's all asteroid view is, so that one's really easy. We'll move that into supporting files as well. Here is a little file of extensions that I made to CG float and CG size and CG rect. And CG point. These are just little convenience functions, like here's the area of a CG size, right? Just width time height. Or here's a CG float. It generates a random number in a certain range of floats, which is kind of cool. A random float, okay, and returns it. Here's CG rect. I have random point, which generates a random point inside the rectangle anywhere. Because obviously I'm going to put my asteroids at random place in the rect. It's nice to have a little var here, random point for rect. So you can go look at these later. As I'm writing the code, I'll try and reference, oh, this is one of my little CG rect extensions that I did. And I do this because I think my code reads a lot nicer when I, kind of condense this math into these nice little extensions. But all of these make perfect sense as extensions of each of their classes. None of them are spaceship or asteroid specific extensions to core graphics. So I'll move that to supporting files as well. Then next we have the spaceship view. Okay, the spaceship view just draws that little spaceship I showed you. It knows how to draw it with the little flame coming out the back if the engines are firing. This is the entire public API of it right here. This is the only API we'll be using. So that's just a Boolean that turns on that little fire coming out the back or not. That's all it does. Direction is the direction the ship is pointing, and that's 0 to 2 pi. So it's in radians. We've hopefully learned by now the 0 to 2 pi circle where 0 is out to the right and we go around. Shield level, so this ship has a little round shield around it, and the shield level goes from 0 to 100. When 100, it's a full shield, and it doesn't even show the shield. But as soon as the shield gets damaged, it kind of shows the shield partially damaged. Until you get to shield level 0, the ship explodes, okay? This shield is active. It's purely a drawing thing. When the shield is active, it kind of glows a little bit. And so we're going to have our ship, just to make our UI simple, it's going to automatically turn its shields on when an asteroid impacts it. Okay? So we're kind of an auto shield deployment. So we're going to turn this on so we can see it, the asteroids causing the shields to turn on. And then finally, there's this little shield boundary guy. That just gives us a UI Bezier path that describes the shield. It's just going to be a simple arc around because it's a circle. Just gives us that back. Notice that it can give it to us in any view's coordinate space, and that's because we're going to find that when we do animation, we're going to specify a reference view for all of our animation, and when we have these things like boundaries, we have to always specify them in that reference view's coordinate system. So if we're going to get the boundary of the ship shields as a UI Bezier path, it has to be in the right coordinate system. So that's why it has this in view argument right there, but it just returns a UI Bezier path. Okay, so that's the spaceship view. Not going to do anything else with that. And then here is the last one, the asteroid field view. This is the entire thing right here. It only has one method in it, which is add some asteroids. Okay, and all this code in here is doing is just putting a random sized asteroid at a random point inside its bounds. So it's really super simple right here. It does have this little thing of exclusion zone where it won't put an asteroid there, and you'll see why we want that. We don't want to put an asteroid on top of our ship when we start. Now this one I'm not going to put in supporting files because we are going to actually add a small amount of code to this guy because we want our asteroid behaviors, how our asteroids behave using dynamic animation, to apply to all of our asteroids. And so we're going to end up adding a var here so we can set the asteroid behavior in this asteroid field view, as you might imagine. Okay, so I'm going to rename my generic view controller here to be asteroids view controller. Just a good review of how we do that, by the way. We have to do kind of 4 things. I renamed the comment, the actual name of the class. I'm going to rename the file. I'm going to be typing the word asteroid a lot today. And I'm going to go to the storyboard, of course, and select this thing and make sure that its identity over here is not generic view controller, it's asteroids view controller. Okay, everybody remembers that? How to change things? Pretty easy to do. And then, don't need any of this code for now. I'm also, obviously, as you imagine, when you do a game, you have a lot of constants. Okay, constants for ship acceleration and the size of things, whatever. So I have a bunch of constants, which I'm going to type in here. And I'm going to go over these constants as I use them. But like I say, burn, acceleration, initial asteroid count, these kind of things, they're pretty obvious what most of these constants are. Okay, so now we're all set up to write our app and focus on our UI dynamic animation that we need to do. the first thing I'm going to do is put the asteroid field view in my self.view. Okay, so basically put it on screen. And I'm going to do that in code instead of doing it in the storyboard, but it's pretty straightforward. So I'm going to have a private var, which is going to be my asteroid field, and it's going to be of type asteroid field view. Okay, that's this thing right here that I showed you that we know how to add asteroids to right there. And I'm going to make this an implicitly unwrapped optional because once I initialize that field, it's always going to be set for the entire lifetime of this MVC. So it's okay to make it implicitly wrapped optional. I just have to be a little bit careful, just like with an outlet, not to access this, or at least to check that it's nil, before I initialize it. And when am I going to initialize it? I'm actually going to initialize it in viewDidAppear. Okay, so in viewDidAppear, I'm going to initialize this. And why am I doing it there? Well, I really don't need to do it before then, right? Until my view appears, I don't really need to initialize its asteroid field and all that stuff. Also, it's nice, in viewDidAppear, all your bounds are set, right? Your geometry is all set up, so you can count on that. But I'm not going to rely on that because I'm also going to have my asteroid field thing work when I rotate. So I'm also going to have to kind of adjust my asteroid field in my viewDidLayout subviews, right? Because that tells me that my bounds have changed. So I'm going to do both. So all I'm going to do here in viewDidAppear is I'm going to call something called initialize if needed, because it might not be needed. Remember that viewDidAppear gets called multiple times because you could appear and then go away and then come back and go away. And so I only want to initialize the first time, so I'm going to initialize if needed. And so I'll have this private func for that, initialize if needed. And the if needed part is just if the asteroid field is nil, then I need to initialize the asteroid field. Okay, so everybody cool with where we stand right now? So what do we need to do to create this asteroid field? It's just a UI view. So I'm going to create it. I'm going to say asteroid field. Let's make some more space here. Let's get a little wide here. It's an asteroid field view. Asteroid field view. Okay, view. Oh, capital A. All right. And a view, how do we create a view? Well, we're just going to use the normal frame initializer there. And what is the rectangle of my my view here? I'm actually going to start by having my entire asteroid field fit inside my view's bounds so you can see the whole thing. But when I really get going with my game, I'm going to make the asteroid field quite large so that my ship has a lot of space to fly around in. And then I'm going to use a little bit of gaming design trick, to make it so that it seems infinite, but of course I can't build an infinitely large view. So I'm going to build this with a rect that is centered at my self.view's bounds mid. So mid is something I added in my CG rect extensions. It just gives you the midpoint of it. And my size is going to be my view.bounds.size. Okay, now I'm going to start it out there as, in the center, covering my whole view, again, just so you can see what's going on there. And one more parentheses. What else we need to do? Well, we need to add it as a subview. Okay, so I'm just going to add this asteroid field as a subview of my self.view. I'm in my controller here. And then let's add some asteroids. Asteroid field.add asteroids. We'll add 20 asteroids. That's a good number of asteroids. I think I might maybe even have a constants for this. Constant dot initial asteroid count. Initial asteroid count. That's better. Have a little constant there. The other thing, like I said, is when my bounds changed, I want to make sure I move my asteroid field always to the center of my new bounds. Now that's going to be a little funny now because my field's going to start out being this, the bounds size that I start out with, and I'm not going to change it. But when I make my bounds really big, I'll make it so big that no matter what I rotate my device to, it'll always be showing part of the field. So I won't worry about that too much. All I'll do for now is in viewDidLayout subviews, I'll just make sure to always recenter myself by saying that my asteroid field's center equals my bounds mid, right? So just always put it back in the middle. Okay, everybody cool? What I've done so far? All I did is created this asteroid view. Let's run it and see what our asteroid field looks like. It's just going to be a bunch of randomly sized and positioned asteroids plopped in there. All right, here it is. Okay, here's my iPhone 7 Plus, nice big one. And you can see I've got all these randomly sized and shaped and, different ones, those 9 different asteroids in here. Now it's time to learn about dynamic animation. We're going to make these things move. Now, how do we make these asteroids start floating around in space? And the answer is we're going to push them. We're going to use a push behavior and give it an instantaneous push till these things just fly off. So we'll push them all a random amount in a random direction. So they all just start moving in all different directions. Now, to do that animation, we always need this top level thing, which is an animator. Okay, the animator is the thing that controls all the animation. So if you're doing dynamic animation, you're always going to have a private var, which is, you'll usually call animator, which is going to be a UI dynamic animator. And its initializer takes a reference view. And this reference view is just defining the coordinate system that all the boundaries for collisions and things like that are going to occur in. Now, what I want this reference view to be is my asteroid field. That makes the most sense, right? Everything's in the asteroid field. That's a good view. I can choose really any view that's high up in the hierarchy that I want to animate. Now, here we're having the same exact problem we had in the last demo, where I'm trying to initialize a var. And in part of an initialization, I'm trying to use a var. And we know we can't do that. We can't use any of our own vars or funcs until we fully initialized ourselves. So we're going to do lazy. And we know when we do this lazy approach, we have to explicitly type. We can't use the static typer here, animator. And also, we know that if we just say asteroid field, it's going to be looking for a static, a class, method called asteroid field. So to tell it we want an instance one, we're going to say self.asteroid. And this is going to work because it's going to be lazy, and so it's not going to actually execute this initialize in here until somebody asks for it, and nobody's allowed to ask for it until we're fully initialized. And thus, we've gotten out of the conundrum there. Okay, everybody cool with that? So now we have an animator. What's the next step in animation? Behaviors. We have to create behaviors. And so our asteroids are going to have a lot of behaviors on them. Okay, they're going to be colliding with things. They're going to get pushed. They're going to have general kind of physics. They're, even when the ship is accelerating through space, they're going to even be experiencing opposite direction acceleration. So we're going to combine all of those into one single behavior. Okay, a subclass behavior, and that subclass behavior is going to be a composite of all those other kind of behaviors. So let's do that right now. Let's go File, New, and create a new class, which is going to be a UI dynamic behavior. You see it says subclass of UI dynamic behavior here. I'm going to call it asteroid behavior, because that's what it is. It's the behavior. It's going to collect all the behavior that has to do with asteroids. Put it where I put everything here. And so here's my dynamic behavior. All I'm going to do to start is have an add asteroid and a remove asteroid method so that I can collect the asteroids that I'm causing to behave somehow. So let's have a private var, which we'll call asteroids, and it's just going to be an array of asteroid views. Okay, and then we'll have a private, or actually a public func called add asteroid, and you're going to give it an asteroid, and it's just going to add this asteroid. Okay, append this asteroid onto the our array of asteroids here. And then we're also going to have remove asteroid. And this one has to first make sure that we actually have this asteroid by saying if we can let index equal asteroids.index of this asteroid. Okay, if we can find it in there, then we're just going to say asteroids remove at that index. Okay, so this is it so far for our behavior. It's not actually doing any behavior, but now we can add asteroids and remove asteroids from the behavior, which is a critical part of animation. Remember, there's always 3 steps. You've got the animator, you add the behaviors to the animator, then you add the items, the asteroids in this case, to the behaviors. And so this is we've done all 3 of those steps. Now we haven't actually picked any behaviors to composite to build our thing out of yet, but at least we got the infrastructure to do that. Now we have a behavior here. Let's go back to our view controller and create one of these behaviors, instantiate one, okay, and add it to our animator. So we can instantiate one by just saying private var asteroid behavior equals asteroid behavior. All right, so we just created an asteroid behavior there, but it won't do anything. That behavior, whatever we tell it to teach it to do eventually. It won't do anything to the asteroids until we add it to an animator. Now, when's a good time to add a behavior to an animator? Well, you really only want animation to go on when you're on screen. Okay, if you're not on screen, animating things probably 99% of the time does not make any sense. So kind of a cool place to do it is in view did appear. So when my view appears, I'm going to tell my animator to add behavior, my asteroid behavior. Okay? Now, when do I want to remove it? Well, I want to remove it when I disappear. So in view will disappear, no, that's not even close. View will disappear. Super.view will disappear. Animated. Here I'm just going to say to my animator, remove this behavior. And as soon as I remove a behavior from an animator, it will stop animating that behavior. Okay? In other words, that behavior will no longer apply to the animation that's going on. I can put it back and it'll start animating again. One thing that's interesting to note though, all the items that are being animated, if you take an animator out of an animator, they'll lose all their linear velocity. They'll stop moving. So if you add it back, they'll all be stuck. You'll have to re-push them or re-establish their linear velocities or something like that. Okay, that's the only bad part about stopping. You can't really, this is not really pausing the animation, it's stopping. All forces stop on things being animated, and then when you add it back, they all start reapplying again. But if the ship were accelerating when you removed it, and you come back and the ship keeps accelerating, those things will still be accelerating, still be affected. So now we've added the asteroid behavior to the animator. What's the next step? We got to add the asteroids to the behavior. Okay, if we don't add the asteroids behavior, nothing's going to happen. And I'm actually going to have my asteroid field view do that because it's the thing that creates the asteroids. And so it kind of works for the architecture of my app if I only have it deal with the asteroids and I don't have to actually deal with any of the asteroids at all in my view controller. That's kind of cool. So I'm going to go back over to my asteroid field view right here, and I'm going to add a public var here, which is the asteroid behavior that I want to apply to all of my asteroids. So we'll have it be an asteroid behavior, of course. And we'll have it be optional because maybe my asteroids are just sitting there, not behaving. No one's put their behavior, so they don't do anything. They just sit there. That's probably fine. When someone sets this, okay, someone sets my behavior, I want to remove all my asteroids from any previous behavior I had and add them to the new behavior. Okay, I don't want, when I set this asteroid behavior, I don't want any old behavior to still be behaving. So I'm actually going to go through all of my asteroids here for asteroid in asteroids. Whoops, in asteroids. And for each one, if I had an old value that was not nil, old behavior, then I'm going to remove this asteroid. Oops, remove asteroid. Okay, and similarly for the new value, the new asteroid behavior that I have, if that's not nil, then I will add asteroid. Okay, now what about this little var right here, asteroid? Where are all my asteroids? I don't have a var here for my asteroids. I actually waited to do this instead of just putting it in advance because I want to show you some kind of a cool way to do this. I'm going to have a private var asteroids. It's going to be an array of asteroid view. And it's going to be calculated. And the way I'm going to calculate it is I'm going to return all my subviews, okay, because all my subviews are all these asteroids. But maybe one day I'll add some other kind of subview besides an asteroid. I don't know, a space station or something. And so I only want my subviews that are asteroid views. So I'm going to say subviews.flatMap. Okay, now flatMap takes a closure. And if that closure returns nil, it doesn't add that to the thing, to the return value here. And if it doesn't return nil, it does. And so in other words, flatMap makes a new array with all the things in the first array, but with this closure executed on them, and it skips ones that are nil. So I'm just going to say $0, which is each subview in the array, as an asteroid view. Okay, and this will return nil, of course, if I have a subview that's not an asteroid view, but all the other ones will do that, and that makes this return value turn into an array of asteroid views. Okay, so I just thought I'd show you a flat map there. It's kind of fun. All right, so now we have this asteroid behavior thing. The other thing we probably want to do is when we add a new asteroid, if we have our asteroid behavior set, let's go ahead and add this asteroid to there. So in asteroid behavior, I'm going to add asteroid, this asteroid. So you can set the asteroid before or after you add the asteroids. It'll work either way with this. So now we need to set, see this var right here? We need to set that from our controller so that our asteroid field view right here knows what behavior to use. So we're going to say here, we'll put it even a little higher, we'll say asteroid field, set your asteroid behavior to our asteroid behavior. And again, it doesn't matter if I do it before here or I could do it after here. Either way, it's going to work. Okay, got that? All right, now we're all completely set up. We have this behavior, custom behavior, which doesn't do anything yet. All the asteroids have been added to it. Okay, it's been added to an animator. All we need to do now is implement our behavior. And however we implement the behavior, it's going to start applying to all of our asteroids. So I said the first thing we want to do is push them all. So let's go add a pushing behavior to our asteroid behavior. So here's our asteroid behavior right here. Let's add a push behavior. And I'm going to do this push behavior by creating a func called push all asteroids. Okay? And I'm going to have an argument to this push all asteroids, which tells how much you want me to push them. It's always going to push them in a random direction, but you can say by how much. And so I'll call it by magnitude. And I'll even let you specify a range of magnitudes to push, because you don't want to push all of them the exact same amount. So we'll create a this is going to be a range of a range of CG float, and we'll have a default. How about the default be 0.5? So between 0, which means don't push them at all, to 0.5, which means push them a fair amount, but not really hard. A 1.0 push is a pretty good push. And these are the kind, I probably should have a constant for this, but these are the kind of things you'll play with these numbers till you kind of get the feel for the animation that you want, how fast you want them to slide in, or how hard you want something to be pushed, or whatever. Okay? So how am I going to push these asteroids? I'm going to do it with a push behavior. So I'm going to go through each of my asteroids. Okay? And for every one, I'm going to create a pusher, which is going to be a UI push behavior. And the UI push behaviors creator here is this one, items. So a push can actually push multiple items at once, but I don't want that here because I want to push all 20 asteroids or all my asteroids in different directions, so I don't want to push them all in the same direction. So here I'm just going to have the array have one thing in it, the asteroid that I'm doing right now in my for loop. And the mode can be continuous, which means I just keep on pushing it forever. So that's basically velocity. Push behavior that's continuous is velocity. Or it can be instantaneous, which is one push. And that's what I want here. I just want to kind of get them started, but I'm not going to keep pushing my asteroids around. I'm just going to push them around, and hopefully they're in outer space. They'll just keep on moving, right? Well, we'll see if that happens, but hopefully it will. And so the pusher's magnitude here is how hard you're pushing it. And so I'm going to make the magnitude be a random number inside this range up here. That's why I have the CG float random in range. Okay, so that's what I'm going to do. And then the angle I'm going to pick is also going to be a random number, CG float.random. And that's going to be in a range of 0 to 2 pi. Okay, so they can push in any angle all the way around the arc of radians, right? So now I've set up my pusher. I just need to get it to push. And how do I get it to push? Well, to get it to push, I have to add it to a dynamic animator. Okay? As soon as I add any behavior to a dynamic animator, it starts. So here I just need to add it. And how do I do that? Well, here I'm creating a subclass of UI dynamic animator. And so the way we add behaviors is we say add child behavior. Okay? And that adds this pusher, this one-time instantaneous push, to our behavior, the asteroid behavior. And of course, the asteroid behavior has been added to a dynamic animator, and that causes the push to be animated as well. So basically, all the animation gets propagated down through our asteroid behavior to all our children, all our child behaviors. And we're going to have quite a few, 4 or 5 child behaviors here. All right? So let's go ahead and see if this did anything. Oh, wait. One thing we've got to do first is call this. We never actually call push all asteroids, so let's do that. Let's push them, again, when we first appear, we'll give them a push. So we'll say put behavior, asteroid behavior, push all asteroids. And we'll use the default magnitude. It's fine. we don't really care that much, as you'll see soon. But it's kind of nice to give our asteroids some kind of initial motion in space. And you can see there, we pushed them. Now, something bad happened, though. They got pushed out into oblivion. We lost them all. And they're still going, but I think there's one over there and one way over there. We can't see them, obviously, anywhere in our view because we pushed them all out of our view. So that's a major problem we need to fix, is having these things go all out of the view. So we'll fix that. The second thing, I don't know if you noticed it, but they actually started to slow down pretty quick. Okay? They started out really fast, but then, they rapidly slowed down. Okay? And in space, that shouldn't happen. Now, the normal physics of a dynamic animator are kind of like a tabletop by default, which if you push something, there's some friction there, right? And so things would slow down. And this is not a tabletop, this is outer space. So the two things we need to fix is one, keep our things from flying everywhere, and two, make it more like outer space, no friction, things like that. Okay, and we're going to fix each of those things with a different sub-behavior of our asteroid behavior. The first one of them flying all over, for now, I'm going to put a little boundary around my entire view, my reference view here, so that the asteroids hit that boundary and bounce back. So they're all kept in here. Now that's not going to work for my game, as you'll see, because yes, you're flying through space. The asteroids don't bounce back out of some invisible wall and come at you. New ones are always coming, and we'll talk about how we're going to do that trick in a minute. But first, I just want you to see how collision behavior works. So I'm going to add a boundary, which is all the way around this reference view. Okay? So how are we going to do that? So let's go back to our behavior. Okay? To do a collision boundary like that, we're just going to create a private var, which is going to be, I'll call it my collider, and it's going to be a UI collision behavior. Now, anytime we add a new behavior, we need to do this add child behavior thing. And a good place to do that, actually, is in init. So I'm going to override init here, call my super init, and then I'm going to add this child behavior, the collider. And that, again, means that as soon as I get added to an animator, the collider gets added to an animator, so it will animate as well. The other thing we need to do is add all of our asteroids to this behavior. Just because we add a child behavior, it doesn't mean it applies to all of our items. We might not want that. We might not want the collision. In fact, later we're going to find we don't want our collider actually to apply to the asteroids, for example, we want our collisions to happen with the ship. Okay, that's how we're going to do it. So how do we do this? We do this by going down here where we add a new asteroid. Every time we add a new asteroid, we're going to say collider, add item, asteroid. And same thing down here when we remove, we're going to say collider, remove item, asteroid. Okay? So don't forget those two steps. In fact, let me move this code up here next to the init so you can see. They kind of go together. These three things right here. Adding a child behavior and then adding the item. We're going to do that over and over for all of our sub behaviors that we're going to create. Okay, now, we have this collider, but we have to configure the collider to say, what do we collide against? And remember, I want the outer bounds. I want the asteroids to collide with the outer bounds. For fun, I'm also going to make the asteroids collide with each other, okay, to start here. So let's see what that looks like. I'm going to do this same trick here, private lazy var. And I'm actually going to initialize this collider using a closure. So it's a collision behavior. And it's going to equal a closure that I'm going to execute. Okay? And inside this closure, I'm going to do this. So I'm going to let behavior equal that. And I'm going to return that behavior. Okay, so this is a way you can initialize a var and do some initialization stuff here, right in line. Okay, so what do I want my collision behavior to do? So I want it to have a certain mode of collision. So let's talk about that. Collision mode is a var in behavior. And there's three different ways you can set this. One is collides with everything. So everything means everything collides with everything. Boundaries, items like asteroids, they're all colliding with each other. That's what we're going to do. But the other options would have been boundaries, which means it only collides with boundaries. And we're going to talk about how to add boundaries, Bezier paths as boundaries. Or you can have only the items colliding with each other. like just the asteroids collide with each other, but they don't collide with any boundaries. Well, here I'm going to have it collide both with the boundaries and with each other. So the asteroids are going to be bouncing off each other and with the boundary. Now, how about that boundary? I want a boundary that's all the way around my reference view. It turns out there's a var to just do that automatically called translates reference bounds into boundary. If you set that to true, it'll add a boundary, which is a rectangle around your reference view. Now, we're later going to show how we can put boundaries in by specifying Bezier paths, like the ship. The shields of the ship is a Bezier path. But for now, we'll just do this simple one here. Now, I don't have to do anything anywhere else in my code. I can, since I've set up this asteroid behavior, I can just keep adding behaviors to it, and it'll just apply to the asteroids. I don't have to go back to my controller and do anything. Okay, my controller already has created an animator and added this behavior, so there's nothing more to do. So let's go see what this looks like. Now our asteroids that we know won't fly off into oblivion, at least. Okay, there they are. And you can see they're bouncing off each other, and they're hitting the walls, and they're also slowing way, way down. Okay, that's that bad friction thing going on there. All right, so how are we going to fix the friction? We want these things to just kind of keep bouncing around and not stop like this. We want them to feel like they're in outer space. Well, to do friction, we actually need a different kind of behavior, which is called the dynamic item behavior. And a dynamic item behavior, talked about it in the slides, is kind of a meta behavior. It's going to describe the physics of how these things work when other behaviors act on them, like colliders. Okay? So when the collider hits, we're going to be able to describe how bouncy the hit is, for example. And we get to say whether there's friction and whether they slow down and things like that. So let's create one of those, private lazy var. I'm going to call mine physics, because that's what it kind of feels like. You're specifying the physics of your all your asteroid views. And it's a UI dynamic item behavior. Don't get confused here between dynamic item behavior and dynamic behavior. Okay, dynamic behavior is the root of all, it's the superclass of all behaviors. This is a specific kind of behavior, just like a collision behavior is a behavior, so is a dynamic item behavior. Okay, people confuse those two because they're so similar in name. But I'm going to do the same thing here. Let behavior equal a UI dynamic item behavior. And I'm going to return that behavior out of this closure. Everyone understand, right? I'm got a closure here. I'm returning this behavior out of that closure, which I'm executing, and then it's assigning it to this, and it's doing it lazy. All right, so what kind of things can we set in this physics, like this meta behavior? Well, what are things we want here? Let's try the elasticity, how about? So elasticity says when two things collide, for example, how much energy does it lose? If you have an elasticity of 1, that means they don't lose any energy, at least no linear energy. If they spin, then they might lose linear energy and gain angular velocity. But elasticity means that they're bouncy, right? Now, an elasticity of 2 would mean they gain energy. So they bounce off, now they're going faster coming out. And a 0.5 would mean they'd be slowing down. So 1, since we are going to allow our asteroids to spin, our asteroids will kind of generally slow down, but over a much longer time than they were before. Because our elasticity before was, I don't know what the default is, but it's very low. Speaking of spinning, let's make it so that our asteroids can spin. And we can just do that here by saying it allows rotation true. So that says when there's a collision, the views can spin, okay, like an asteroid would. Of course, we want that. How about friction? Let's set our friction to 0. Okay, no friction. We do not want these slowing down because they're running across the tabletop. They're in outer space. And there's also a similar one here called resistance, which I'm also going to set to 0. Resistance is how much items resist the forces being applied to them. So if you set a very high resistance, then they're resisted a lot. Now, why do you want resistance? Well, you might have a gravity field or something like that where some things are getting pulled fully by gravity, but other things are not, like they're a balloon or something. I don't know. They float more or whatever. So you'll be able to control their resistance. You can put them in the same behavior, like same gravity behavior or same collision behavior, but you can control how much they resist those things. All right, so we don't want any resistance. We want, when they collide, full impact. So this physics behavior, just like the collider, has to be added as a child. and it has to be, and the items all have to be added to it. So physics, and we need to add item here. Asteroid, sorry, asteroid. This is physics over here, physics. And same thing here, physics. You'll often forget to do these steps right here. You'll add a nice behavior and you're like, oh, you forgot to do this, and it won't apply, of course, because until you add the items, and then, unless it's a child behavior, then that behavior won't affect anything. All right, so let's see what this does. See if this fixes our problem by adding this behavior. Okay, yeah. See, they're not slowing down. Or, I mean, they are actually, but they're slowing down so slowly you can't really tell. And they're all bouncing at each other, and they're spinning, and some of them are going quite fast, actually. Got it? Okay, now, this would not be a good asteroid game because your ship would be getting crushed in this asteroid field. But we're going to put our ship in here anyway. We're going to put our ship right in the middle, just so I can show you how the shields work. And our ship is just going to get battered here. So let's add our ship. So I'm going to go back to our controller here. And in the same place where I initialize my asteroid field and create my asteroid field right there, I'm going to create my ship here as well. How big is my ship going to be? Well, I want my ship to kind of be a good size relative to the size of my view bounds, right? My self.view. So I actually have a constant for that, which I think is 1/5. So I'm going to make my ship be 1/5 of the shorter side of my bounds. Whichever side is shorter, I'll make my ship be 1/5 the size. So let's let ship size equal my view.bounds.size.min edge. That's another one of the things I added in my core graphics thing. So I'll take whatever the min edge is, and I'm going to multiply it by a constant, which is the ship size to min bounds edge ratio. Let's go take a look at that and what I set it to. Here's my constants. I set it to, to 1/5. So it's 1/5. So the ship is 1/5 the size of the minimum edge, which seems like that's pretty good, balance size. My ship might be a little too big on an iPad, so I might want to play with that, but we'll see. So now I've got the ship size. Now I just need to create the ship, and it's just a view. So let's go up here and create a var for it, just like we have our asteroid field. Let's do var ship. We'll call it a spaceship view. And we'll also make that be implicitly unwrapped optional because we're going to initialize it right here at the start. And so we'll say our ship equals spaceship view, and frame. And we'll do a CG rect here. And let's have our ship be centered on the asteroid field. So we're going to put it in the asteroid field's center. And of course, we know the size is the ship size. And actually, I want it to be a square, so I'm going to use a different CG rect thing that I have, which is square centered at, I think I called it. I typed that right. Yeah, squared centered up. So a ship is going to be a square centered at the asteroid field center, right in the middle of the asteroid field, and it's going to be that ship size that we calculated right there. So let's add this ship to our subviews. Now, notice that I've added the ship to my self.view as a subview. So it's a sibling of my asteroid field. It's not a subview of my asteroid field. My asteroid field really the only subviews it has is all those asteroids. But I decided I'm going to put my ship at the same level there. And what's it complaining about here? Sorry, let's see here. Yes, view add subview. We've got to add it to our self.view. We're in our controller right here, not in a view. Okay, so there's our ship. Let's go take a look at our ship actually right now. There's no collisions going to happen. Our ship is not involved in the asteroid behavior, right? We haven't added our ship to the asteroid behavior in any way. So there's our ship. It's pointing at 0, which is off to the right, and the asteroids are just flying. They're behind it because the ship was added to the subview later, so it's in front, right? We know that our subviews are in order from back to front. Okay, so now we want these asteroids to collide with our ship's shield. The ship's shield is just a round circle around our ship, and we want it to collide there. So we're going to have to add a little more to our collision behavior code over here in behavior. Because right now, all we're doing is having everything collide with everything, and the reference bound is our only boundary here. So I'm going to do this by adding another func. This is going to be a public func called setBoundary, and it's going to let you set a UI Bezier path as a boundary. And it's going to be able to have a name so we can refer to it later. You'll see why we need to be able to do that. And then another cool thing, how about if we add a handler so that if there's a collision with that boundary, we call the handler for you. Wouldn't that be cool to use closures in that way? So let's do that. Handler, what's the type of handler going to be? Well, it's just going to be takes a void, returns void. In other words, doesn't have any arguments or whatever. And I'm actually going to make it optional as well. So you don't have to do a handler. You can put a boundary and the collisions will happen with it. But if you don't put a handler, then no one ever finds out about it, right? I got too many parentheses in here, maybe? That one? Yeah. All right, so we got that. So how are we going to implement this set boundary? Well, first we've got to add this boundary to the collider, right? We've got this collider behavior up here. We need to add this new boundary, this Bezier path, as an area that it's going to collide again, and that's easy. Collider.add boundary. Okay, the boundaries, when you add them, need an identifier. Okay, which makes sense because when the collision happens, you got to say which boundary you collided with. So we'll use name for that, but remember this has to be an NS copying. So we're going to say as NS string here, because NS string and NS number are both NS copyings that you can use right here. And that works because string can always be ased to NS string and back. Okay, it's a special little relationship between those two guys. And okay, we're going to add the path here. Okay. Now, the only thing about this, though, is what if someone sets the boundary again? Then we pretty much want to remove the old one. So I'm also going to say collider.remove boundary, the name as NS string, to get it out of there. Not remove item. Remove boundary with identifier, name as NS string. Sorry about that. Okay, so I'm going to remove the boundary, and I'm only going to add the boundary, actually, if you specify a path. So I'm going to make this path be optional, and then we'll unwrap it there. I'm only going to say if the path does not equal nil, then add the boundary back. That way, if you say set boundary nil, it'll get rid of the boundary with that name. So it's a way of kind of having one method to both add and remove boundaries. Now, what about this handler? Okay, we got to somehow hold on to this handler so that when a collision happens sometime later, we can call this handler. So whoever created this boundary can find out, oh, you had a collision there. So I'm going to create a little private var here called collision handlers, and it's going to be a dictionary. And that dictionary's keys are going to be strings. And what do you think the var, or the value of this is going to be? How about a function? Okay, so I'm just creating a dictionary whose keys are going to be the names here, and whose values are going to be the handlers. Okay, and I know it's taking you guys a lot, some of you a lot, to really get comfortable with this idea that functions are just types. It's no different than a string right there. Okay, and so we can have a dictionary full of them. It's very, very nice and easy to use. So we want to do the same thing here to remove the old one. So I'm going to say my collision handlers of this name equals nil. So I'm removing any old handler for this. And when I add it in here, if there's a new path, I'm going to just say collision handlers subname equals the handler. Okay, so now I'm keeping track of those handlers for each of these named boundaries, right? These boundaries have names, and I'm keeping track of the handler. So how do I call this handler when a collision occurs? Well, we need to find out about collisions. So here's how we find out about collisions. We do it with a delegate. It's the delegate of our collision behavior. So we're going to go up here to our behavior, collision behavior, and say that it's collision delegate. It's not called delegate, it's called collision delegate, equals, and I'm going to have it be self. So this asteroid behavior itself is going to get the notification that a collision occurs. So that means I have to be a UI collision behavior delegate to do that. All the methods in there are optional, so I successfully implemented that delegate. But of course, I want to implement one of the methods, and so let's look at some of them. So I'm just typing collision here so I can see what they are. You can see there's 4 of them. There's begin and end contact, you see, begin and end contact for boundaries or items. So I can find out if items are colliding, or I can find out if items are colliding with a boundary. And of course, I want the boundary collisions. And I pretty much want the began. So when the contact starts, okay, if impact first happens, I want to find out about it then. So I'm going to pick this one, began contact for item with boundary. Let's look at the arguments here more clearly so you can see them. All right, so this is the collision delegate method that gets set when a item, an asteroid view, impacts a boundary, like the ship's boundary or even the reference bound's boundary. And it even tells you at what point in the reference view the two things touched, okay, which is kind of nice. Now, we could even have had our handler take that CG point as an argument. We could have told the person that, but we kind of have a dumb handler here. It could be better, but we'll leave it with what it is. All right, so what do we want to do here? Here we want to see if, first of all, I want to get the name from that identifier. So if I can let the name equal that boundary identifier, this thing right here, and it's an NS copying, and it's also optional, so I'm going to say as string. So if I can get that identifier as a string, which it needs to be if it's a handler here, there might be other identifiers in there for other boundaries that you create, but it's got to be a string if we're going to do this. And then also I'm going to let the handler equal our collision handlers sub that name. Okay? So if I can do those two things, I can get the handler for that collision. And what am I going to do here? Call the handler. All right, this is a little bit sophisticated implementation here. I'm using closures and all that stuff. Hopefully you're understanding it. If you're not, make sure you follow up with Piazza or with the TAs and office hours or whatever. But this is the kind of thing, this is the kind of coding you want to be able to do in Swift, okay, using closures to cause things like this to happen. So this is the public method right here that we are going to use in our controller. We need to set a boundary, which is the ship's shields. And in the handler, we're going to do whatever we do when an asteroid hits our ship. So let's go do that. Let's go back to our controller here. Now, where do we want to set that boundary? Now, this is kind of interesting. You would think we might want to set it right here in initialize if needed. But it turns out we can't do that, or at least not only there. And why is that? That's because this boundary, we're setting it in the behavior, it has to be in the reference view coordinate system. And that boundary is going to change position when we rotate our device. Okay? You know that when you rotate your device, your bounds change, and the center is in a different place. Okay? The coordinates of it are different. So that's why we need to reposition our ship every time our bounds changes. So we'll do it in initialize if needed, but we're also going to have to do it in view did layout subviews. Okay? So let's create a private func to do that. We'll call it reposition ship. Okay? This is every time the ship changes position. And we can only do this if we have an asteroid field because we put the ship in the middle of the asteroid field. So if we have no asteroid field, we have no idea where to put it. So if the asteroid field does not equal nil, then we can reposition the ship. And we know that the ship itself, its center, is the asteroid field's center. We don't even need that. It's implicitly unwrapped, right? So the asteroid field center, right? So that's positioning the ship. But now we need to add this boundary around the ship. So we're going to tell our asteroid behavior to set a boundary. Now the boundary is the boundary of the shield, and I told you ship has this nice method called shield boundary. Okay? And shield boundary even takes the coordinate system you want. So we want this to be in our reference view, which is the asteroid field. So that's going to give us back a Bezier path that describes the shield in the asteroid field's coordinate system. We can call this wherever we want. I have a constant for it. I'm going to call it ship boundary name. Oops, not ship size too there. No, ship boundary name. So that's the ship boundary name. And we'll use the trailing closure syntax here. Let's put this on here, so let's go back here. You all know about that. And it has no argument, so we don't really need that. Although I do want to do weak self here, okay, because this is probably not going to be a problem where somehow this animator gets all rogue and starts animating with my controller being gone, but probably I don't need weak self here. Almost certainly I don't. I could almost certainly do unowned self here. But I'm going to go ahead and do it anyway, just for fun. And so we have weak self here. This is setting the boundary. This is our handler that happens when it collides. So what are we going to do when an asteroid hits us? Well, I'm going to have auto shield activation. So I'm going to say ship.shield is active equals true. If we have a collision, bam, I'm going to do it. However, I'm only going to activate that shield for 1 second. Okay? So if you have an asteroid hit you, yeah, I'll put your shield up, but I'm going back down. And if another one hits you, it's going to come back up again. So how am I going to make the shield go back to be inactive in 1 second? Well, I'm going to use a timer. Okay, scheduled. And I have a constant for it. It's called my shield duration. And it does not repeat. And it does this block, which is just going to turn that thing back off. We'll use trailing closure syntax for this one too. And so we're just going to ship.shield is active equals false. Okay, so here I'm just turning the shield on and back off. Now, of course, ship right here is not defined. It needs to be self.ship. So I'm going to say if I can let ship equal self.ship, because self is weak right there, then I'll do this. Now, if I didn't charge any fee for activating your ship's shields, then the shields would just constantly become on, and this would not be much of a game. Okay, so I'm going to charge you some power of your shield to do it. So I'm going to say ship.shield level minus equals, and I have a constant for that too, which is shield activation cost. Okay, so I'm going to deplete your shields every time I turn it on. Everybody got this code? This is super simple. Obviously, if we had a real game, we'd probably have shield regeneration, and maybe the user would have to turn their shield on when they realize they're about to crash into or whatever, but I'm just trying to make this pretty simple and straightforward here. Okay, the other thing I'm going to do is I'm going to have auto-resurrection. So if your ship gets destroyed, I'm going to bring you right back. Okay, again, it's better for our purposes here. So I'm just going to say when this shield gets turned back off, if the ship's shield level has dropped down to 0, in other words, it's been destroyed, then I'm going to set the ship's shield level back to 100. Okay, full shields, boom, it comes back to life. Now, this repositioned ship obviously needs to happen here in view-did-layout subviews. And I'm also going to position this ship right after I create my ship up here, so that the boundary gets created right at the beginning when we're first initialized. Now, one thing about adding this ship is, well, we'll see if it happens. If it doesn't happen, I'll come back and do it. But there's a little bit of a problem with adding this ship with this shield. This you might see. Hopefully, cross your fingers, we'll see the problem here. No, we didn't see it, but oh, so our ship got destroyed really quick here. Why did our ship get destroyed so fast? It shouldn't get destroyed so fast. Hold on a second here. Oh, okay. If our shield is up from a previous hit, we won't let ourselves be damaged again. So here I'm going to say, if the ship's shield is not active, okay, if the shield is not currently active, then I'll do all this stuff. But if the shield is currently active, then I'll just ignore the hit, okay? So when we turn that shield on for a second, we get a second's worth of survival in our ship. Okay, so now we see how when the shield comes on, it kind of is thicker, it's bolder, and then it goes thinner. And you can see it going smaller and smaller, and then the ship explodes, right? And then we auto-resurrect, okay? So again, this would not be a very good game because we got all these asteroids kind of banging in. Now, one other thing that I was hoping would happen, but it didn't, so I'll just have to explain what could happen, is when we put our ship here, what happens if there's an asteroid inside the shield? Okay? It's going to be stuck there forever, bouncing around in there with the ship. So for the purposes of my game, I'm not going to allow an asteroid to be created where my ship is. And that's why this add asteroid up here, add asteroids count, it has another argument, which is exclusion zone. Okay, the exclusion zone is just an area where don't put an asteroid here because my ship is going to be here basically. And so what am I going to put there? I'm going to put the ship.convert the ship's bounds to the asteroid field. I think that's right. Yes. Okay, so sorry, I'm using this convert to method, the same one we used before in a previous demo. And I'm just converting the ship's bounds, its rectangle, from its coordinate system to the asteroid field's coordinate system. So that'll keep us from getting an asteroid created in the middle. All right, so let's make our game a little bit better, because right now the asteroids are just killing us. They're constantly banging our shield. So instead what we're going to do, instead of having the reference bound collider that's keeping all the asteroids in, we're going to let the asteroids fly away, but if they fly outside of our asteroid field, we're going to pick them up and move them around to the other side. Okay? So we're going to create an infinite space by doing wraparound. Okay? I don't think that's how the universe actually works, although we don't know. But that's how our universe is going to work. Okay? Anytime something goes off one side, we're going to wrap it around to the other side. And anytime it goes off the top, we'll wrap it around the bottom, kind of like table view does. And that way we'll only have 20 asteroids in our field, but we'll constantly be reusing them. And the other thing I'm going to do is I'm going to make my asteroid field much bigger. That way the user won't notice that I'm doing this wraparound thing. Okay? So the two things there, well, it's a good, easy, quick simulation of having an infinite asteroid field. So how are we going to make it so these things wrap around? Okay? I don't want to, it's just math to do that, so I don't want to type too much of it in. So I actually have a little pre-typed in thing here to show you that, recapture. So here it is right here. Okay, this is all the code that does that recapturing. The basis of it is a timer. So every half a second or so, I'm just going to look and find all of the asteroids that are outside and move them around to the other side. Okay, very, very simple. So I have this timer, and look, you can see the code right here. It's just looking for ones that are outside. It's using mod, basically, modulo, to move them back to the other side, either horizontally or vertically. And notice here, very importantly, though, when I move them, I tell the animator that I moved them. Because if I don't, let's say I have an asteroid that flies off the field right here, and I move it back. The next time the animator ticks, it's going to move it back over here. You see, because the animator's got a hold of that asteroid. So if I'm going to move the asteroid over here, I have to let the animator know. So that's why we have this line right here, update item using current state, which tells the animator, here's the new position of this thing, keep animating it from here. Okay? Understand that very important line of code right there? I'm also keeping count of the recaptures, because actually it might be kind of a good score for my asteroid game, because the faster I go, the more recapturing is going to be happening. Of course, the more risk I'm taking of smashing into something too. So that's kind of good risk reward. So maybe I could use recapture count as part of or all of my scoring mechanism or whatever. So I have this start recapturing wayward asteroids, which starts the timer, and then stop, which stops the timer. So when should I stop and start this timer that's doing this wraparound business? Well, obviously, if I add an asteroid, I need to start recapturing, okay? Because once an asteroid enters the field, we got to start capturing, otherwise it'll get loose. And similarly, when I remove an asteroid, if I removed the last asteroid, so if asteroids was empty, then I would want to stop recapturing. But that's not all, okay? There's one other time that we want to stop this timer. That's if the animation stops, okay? If the animator stops animating these asteroids off in the universe, then we stop recapturing. Then we don't want our timer running then. So how do we find out that our animator stopped? Well, this method that is implemented in this superclass here, our superclass UI dynamic behavior, called willMoveTo, and it tells you when you've moved to a new dynamic animator, including when you've moved out of all dynamic animators by moving to nil dynamic animator. So let's go down here and put that maybe right here. So it's called willMoveTo. You can see it right there. And I'm going to call super because I inherit it. I don't know that my superclass actually does anything, but I don't want to take any chances. So here, what am I going to do in here? Well, if the dynamic animator that I was added to is nil, that means animation stopped. So I'm going to stop recapturing wayward asteroids. However, if I was added to a dynamic animator that's not nil, now I want to start recapturing as long as I have at least one asteroid. So I'm going to say asteroids is not empty. Is empty. Oh, look at that. Not asteroids is empty. If, that's why. If asteroid is not empty, then I'm going to start recapturing. Okay, so do you see how if my behavior is added to an animator and removed from an animator, boom, I'm going to start and stop my timer that does the recapture as well. So you got to think about these things when these timers are going. You don't want the timers running wild, okay? You got to think about when the appropriate time to start and stop them is. Okay, now that we are recapturing, I don't need this collision boundary here that is the reference bound. So I'm going to comment that out. I'm also going to stop having the asteroids collide with each other. I'm only going to have it collide with the ship's shield. So I'm going to change this from everything to boundaries. Okay, so it's only going to collide with boundaries. The asteroids are only going to collide with the ship, basically. And the other thing I'm going to do is make the asteroid field really big. This is going to make the asteroids larger too, which I think will look better as well. And so I'm going to do that just by see where I create my asteroid field right here. You can see the size is viewed up bounds.size. I've got a constant for how much bigger to make it, so I'm going to multiply this by constants dot asteroid field magnitude. Okay, and asteroid field magnitude, let's look and see what I set it to. 10. So 10 times larger than our view. That's how big our asteroid field is going to be. Now, why don't I make it 100 or 1,000? Okay, well, it's not free to make views that large. Views have backing stores for drawing things efficiently. You wouldn't want it to be infinitely large like that. You want to pick a reasonable size for efficiency. 10 times is fine. Okay, 100 times, 1,000 times, no. You wouldn't want to go 1,000 times. Okay, so now let's see if that worked. Okay, so now here we are in outer space. It's really big. Here come some asteroids. They're just they got pushed, and so they're just wandering around. This is much more manageable as a game, more likely that we could maneuver through these things. But to maneuver, of course, our ship needs some engines. Okay, it needs to be able to move. Now, we're going to have our ship move just like a real spaceship. How does a real spaceship move? Okay, it fires its engines, and what happens to it when it fires its engines? It accelerates. And it keeps accelerating as long as its engines are firing. As soon as its engines turn off, what happens to it then? No longer accelerates, but it keeps its velocity because it's in outer space. Okay, so there's nothing to stop it, so it just keeps going. But it doesn't decelerate, nor does it keep accelerating. It goes no acceleration, but its velocity stays the same. So we're going to do the exact same thing here. So how do we do acceleration like that in behaviors? We use a gravity behavior, because gravity is acceleration due to gravity, due to the Earth's pull, right? Pulling things down. They're accelerating at 9.8 meters per second squared. And we can have the same kind of behavior here. And our gravity behavior is great because we can have it point in any direction. So which direction are we going to have our gravity behavior point? Yes, the opposite direction of the ship. Okay, and that's going to cause all the asteroids to move as if the ship were going here, because we don't actually want our ship to move. We want the asteroids to move. So we're just going to apply gravity in the opposite direction the ship is pointing. Simple as that, and that's going to cause acceleration. And we're going to start accelerating, and those asteroids are going to start moving. If we stop accelerating, they're going to keep on moving because there's no friction in outer space. So if we want them to slow down, we're going to have to turn our ship around and fire our engines the other direction. Okay? So that's how this is going to work. Okay, so let's see if we can do that. Add a gravity behavior to our behavior. So we're going to go back to behavior. Here it is. We got our collider. We got physics. We're going to add another one. This is going to be a lazy var. I'm going to call this acceleration. It's not really gravity. Okay, it's acceleration. Do our engines here. And it's going to be a UI gravity behavior. And we'll also initialize it with a closure. And inside here, we will say let behavior equal a UI gravity. I keep typing graphics there. Let's try. Surprising. Return behavior. Okay, and what do we need to do to initialize this gravity behavior to act like acceleration? Well, when you create a gravity behavior, by default, the gravity is 1.0. That's 1,000 points per second squared in the down direction. Okay, and so we don't want that. We want gravity to start out 0. Because we're in outer space, we're just floating. We're not accelerating, our engines are not going. So we're going to have our behavior.magnitude be 0. Now I could make this private and add API like I did for my collider where I had set boundary, but I'm going to go ahead and leave this public. And what that essentially does, when you leave something public, like an outlet in your controller or something like that, it exports this entire API of UI gravity behavior into the API of yours because you're making this public. So now people can do anything they want to that acceleration var right there. Now the gravity behavior only has a couple of methods or a couple of vars, magnitude and angle basically, also has vector, which is basically the angle. So it's not so bad. We're not exporting that much API. But we also want to be careful when we make a var public that we intend to let people do this, okay, which we do. We're going to allow people to do that. So when we add a new behavior, what do we need to do? Right here. Okay, don't forget these. So let's go here again. Child behavior for the acceleration. And also down here, we've got to add all of our asteroids so they're affected by the acceleration. And we've got to remove items when they get removed. Okay, don't forget that's part of it, won't work. Okay, so that's it. Now we've got gravity. Let's go back to our controller and get our engines to fire. Now, how are we going to fire our engines? We clearly need a gesture to fire our engines. So I'm going to use a gesture called a long press. Okay, long press is a press that you hold down, and as long as you hold it down, it keeps firing. So it's a continuous gesture, like a pan gesture or something like that. But you press and hold. Okay. Very, very similar to a pan gesture, actually. But the long press can be configured for other things like how long to wait until you recognize it, which I'm actually going to set to 0, so it instantly recognizes my finger going down. You can also have long press do things like if you move it, it stops working. Of course, we want our long press to keep following it around, just like a pan gesture. But you can make it so long press, if you move it too far, now it stops firing. So that's the difference. I just wanted to show it to you so you can see a pan gesture, what it looks like. So let's go back to our storyboard here and add that pan gesture. I'm going to add it in the storyboard rather than in code. So here's my controller right here. I'm going to go down and find it by searching for gesture. I'm going to go down these things at the bottom. There's tap, pinch, rotation, swipe. Here it is, long press. I'm going to drag it out. I'm going to apply it to my self.view. So my self.view is going to handle this gesture. Okay, my controller is going to get it. Sorry, the self.view is going to recognize this gesture, and my controller is going to handle the gesture by causing our ship to burn its engines and cause that acceleration to increase. And remember, when we drag this in here, it adds it up here. I can click on it. I can even inspect it. Here's where I can say things like the minimum duration is 0, or the tolerance of how many points you want to allow it to move before it stops firing. If a person jerks their finger away or whatever, you can do all this right here. And I'm just going to have this thing. I'm going to control drag it to cause action to happen. Let's put it right here. So we'll control drag over to here. It's going to do an action. It's going to have the long press gesture as the argument. We'll call this burn because we're going to burn our engines here, okay? So what's going to happen here is when my finger goes down, I'm going to turn the ship towards my finger and turn on the engines. And then when I let go, I'll turn off the engines. Leave the ship in whatever direction it was and turn it off, and it can start drifting. Okay, press the finger down, ship's going to quickly turn. And if I were doing a real app, I'd probably have that turn be animated, but I'm going to have a jerk down there. But you guys know how to do view animation. You could easily have that rotation be animated. And that's how it's going to work. So you press and hold, and it'll accelerate in whatever direction you want to do there. All right, so let's go back to our controller and implement this burn. So here's our burn right here. So how's the burn going to work? Well, I'm going to switch on the sender state. That's the recognizer state. And right from when it began, and also every time it changed, I'm going to turn the ship towards the finger. And believe it or not, I can do that in one line of code. Okay, what did I do wrong there? Maybe just not enough. Yeah. Okay. So how am I going to do that? I'm going to say ship.direction. And I want to set this to where my finger is relative to the center of the ship as an angle, that 0 to 2 pi angle. So the first thing I'm going to do is I have added in my core graphic stuff a way to subtract 2 points and get a vector between the 2 points. So you just use minus to do it. So I'm going to say this is the, make sure I use the right variable names here. Yes, okay. So this is the sender's location in our self.view. Right, this is our controller, minus the ship's center. So that gives me a CG vector, a vector between those two. And vector, I added a method called angle, which turns that vector into a 0 to 2 pi angle. So you see how I can make this really cool one line of code if I have these little CG extensions. So that's something to think about when you're writing your code as well. And then, of course, I want to burn, too. I want to turn on my engines when this finger is turned down. So I'm going to need a private func burn that does that. I'm also going to need a private func end burn, because when I lift my finger up, it needs to stop, which is in the case that it ended, end burn. Okay, otherwise, we'll just ignore. Okay, so that's it. That's my entire burn. Super simple. So what happens when we burn? Well, we need to set that acceleration, gravity behavior, to be the opposite direction of my ship. Also, I want to tell my ship that its engines are firing. Okay, this is just a graphics thing so that it draws that little flame coming out the back. That's all that does. And so now I'm going to say that my asteroid behaviors, acceleration, angle equals my ship's direction minus what? Pi, right? 0 to 2 pi is all the way around, so pi is halfway around that circle. And then my asteroid behavior magnitude. So for the magnitude of the burn, this is something that we would need to, acceleration. This is something we need to play with to kind of get the right one. I have a constant for it so that I can kind of work on the constant, as I'm developing my app. I call it burn acceleration. I think it's, what is the burn acceleration? Okay, 0.07 points per second. That's a really light burn, but as you hold that finger down, that thing's going to start going faster and faster and faster and faster because you're constantly accelerating. Okay, it's not just that you're going fast; you're accelerating, going faster and faster the longer you hold that finger down. Now, the end burn is just tell the ship that the engines are no longer firing, and we'll make the asteroid behavior's acceleration magnitude back to 0. So we've stopped accelerating, and we'll leave the ship pointing whichever way it's pointing. Everyone cool with this little bit of code right here? So that's all we need to do to get this ship a-moving. All right, so here we go. I'm going to start accelerating up towards this guy on the top. See how he's coming down from the, oh no, he hit me. Okay, I'll keep accelerating. Now you're going to see the asteroid start to really rip by me faster and faster and faster in the down direction there. See that? Now, if I want to slow him down, I got to turn my ship around and slow down here. Okay? See? I'm accelerating the other direction. Oh, too late. I destroyed before I do it. But I can still keep slowing down. Slow down, slow down, slow down. Okay, now I'm starting going the other direction. Okay, finally caught up with that one. Now they're going to start going the other way. It's like continuing to accelerate here. Oh, I've destroyed again. Okay? Does everyone see the way that works? Now, if you were playing the actual game, you wouldn't be doing this massive acceleration. You'd be doing little tiny move, look for the things coming, a little more, trying to go another direction, etc. Time for one more thing. I think I'll do one real quick one, which is, if you notice, if I hold down this thing and start accelerating, some of the asteroids start going super fast. I mean, it's just like, it's so fast you can barely see them. They just blink going across. This is another problem we got to fix, is not letting our asteroids be stopped and caught in the middle. But that super duper fast asteroids, we don't want that, because at some point they go so fast the user can't even see them, so they're kind of useless. They're not even on there. So what if we put a speed limit on our asteroids? How would we put a speed limit on our asteroids? Because we can infinitely accelerate our ship faster and faster and faster. So how could we put a speed limit? Well, the way we're going to do a speed limit is we're going to cap the linear velocity of the items. And if you remember from the slides, this dynamic item behavior right here, it knows what the linear velocity is of all its items, and you can set the linear velocity of its items. So in init here, where's our init? I'm actually going to set a speed limit here. Okay? So this little piece of code sets a speed limit on all the items. And how does this thing work? Okay? First of all, I'm going to have a var, which is the speed limit, which is a CG float, and I'm going to set it to 300 points per second. Okay? All these linear velocities are in points per second. And the way this works is it just gets the linear velocity for an item using this linear velocity for method. Then it calculates the excess velocity as a negative number, okay, by subtracting the speed limit, or subtracting the velocity from the speed limit. Caps it out at 0, so that's always a negative number. And then it just adds that negative number back in as a linear velocity. That's always, anytime an asteroid tries to go faster than the speed limit, it slows it back down by adding enough linear velocity, negative linear velocity to slow it down. And we did all this, by the way, with this action thing. Remember the action var, where we can execute a block of code every time that it acts. So the physics are acting all the time because, you know, physics is always being in effect. So now if I accelerate, no matter, even if I keep this engine down full speed, you can see these things, that's as fast as they go right there. They've kind of reached their speed limit, which does appear to be about 300 points per second. This screen, I don't know, it's maybe 1,000 points wide. It takes about 3 seconds, or a little less than that, to go across. Okay? So this action allows us to do it. Now this is executed a lot because this action's happening a lot. So we want this code to be quite efficient. I might even go so far in here as to not call add linear velocity if these two numbers are both 0. I'm not sure whether add linear velocity does anything if those are both 0, but I want this little thing to be so fast that I don't want to take any chances there. And I have to do this. I can't get the linear velocity otherwise, and I have to do this small little tiny calculation, so I'm not worried about those, but this one maybe I would make optional. Okay, so that's it. That's it for dynamic animation. Hopefully, this was kind of fun. Feel free to take it and go add some features to it if you want, but hopefully you've learned all the things we need to do there. And make sure, hopefully all of you submit your proposals and all that, and make sure you're getting started on that final project. Don't wait till the last minute. Use that crossword puzzle mentality where you let things ruminate. Okay? See you next time.
For more, please visit us at stanford.edu.